So this is our next question in projection of solids. A pentagonal pyramid, side of base 40 mm and axis height 70 mm, rests on HP such that one of its triangular surface is perpendicular to HP, comma, parallel and near to VP. You need to draw the projection of it. So in this question they have nowhere mentioned whether the resting entity is a base edge or a base corner. They have just said it rests on HP such that one of its triangular surface is perpendicular to HP, comma, parallel and near to VP. So you have to draw projections of it. So here we have a pentagonal pyramid, as you can see here. So pentagonal pyramid has 5 slant triangular face. And if you keep your question in front of you, this is a special question where you have to position the solid as it is being told. So what they have said is, it is said that a pentagonal pyramid rests on HP, okay, such that one of its triangular surface, so out of 5, any one triangular surface, so let us take this one. So one of its triangular surface is perpendicular with HP. So if you look here right now, the surface is inclined. So perpendicular means you need to raise it like this. So if a surface is perpendicular to it, so this was inclined. If you look at this triangle on the right side, you need to make it perpendicular to HP. Okay, so triangular surface is perpendicular. And the same triangular surface which is perpendicular has to be parallel and near to VP. So I need to turn in this direction. You see this, I have turned like this. So now if you look at the triangular face, that is this triangular face which I am showing you. So that triangular face, if you look with HP, it is perpendicular, right? Plus, it has to be parallel. So with VP it has to be parallel and near. So this is how the solid is positioned, and you need to draw projections of it. It means you have to draw front view. So if you look in the front view, some portion of base will be visible. Okay, so you can see the base. Plus you need to draw the top view of it. So top view will be like this. So this is the third stage, top view, and this is the third stage, front view. Correct? So now we should develop that skill of breaking this third stage or converting this third stage into second and first one. So what we can do is that, as we discussed that in the second stage, the axis has to be either parallel with HP or VP. So we will turn this diagram by 90 degree. Okay, and we'll make only the triangular surface perpendicular with HP, as you can see here. So the base is still in air. And in the first stage, we will make the pyramid to rest on its entire base as we are doing normally. So this is our first stage where the pyramid is resting on HP on its base. So in top view you will find on the right side you will get a base edge. As you can see here, the right side is a base edge. Now this triangular face you want perpendicular with HP, also parallel and near to VP. So in the second stage you will tilt like this such that the triangular surface becomes perpendicular with HP. Okay, and then that same triangular surface, if I tilt in the other side by 90 degree, it becomes parallel to VP, no doubt, but it is near to observer and away from VP. So we want the same triangular surface, parallel to VP and near to it. So you have to turn in by 90 degree on this side, so that the triangular surface becomes parallel to VP and near to VP. Okay, so first stage, second and third stage, turn by 90. Okay, so in the front view if you observe, first stage, second stage, that triangular surface is perpendicular to HP. In the last stage, the same triangular surface which is perpendicular is now parallel and near to VP. So you have to turn in this direction so that the triangular surface is near to VP and away from the observer. Okay, so these are the three stages. So as you've seen in the model, in the first stage, when you keep the pentagonal pyramid with the base on HP like this, from the top view you can see the true shape of the pentagon, and we'll be referring to this triangular surface which will be keeping it perpendicular with HP, so the base edge will be on the right side. So in the first stage, what you have to do is that you have to draw a line of 40 millimeter, mark 108 on both the side, take the same 40, cut on both the 108-degree lines, and then obtain point D to get a pentagon. You may draw two light medians from which you will get O and M and join this dark with dimension 40 mm. Accordingly, you have to draw the front view. A and B will give you A dash B dash, E and C will give you E dash C dash, D will give you D dash, and OM when you project you will get the axis. You have to mark 70 and draw this triangle dark. So this is the first stage what is being done. So first diagram is here, second is here, and third has to be besides. So triangular surface perpendicular with HP. So in the second stage what we will be doing is this triangular surface will be making it perpendicular with HP like this. So if you look in the front view, for the first stage, the same triangular surface was inclined. You have to just tilt like this. So what will happen is the base will not be in HP. In fact, the base edge will be on HP. So we'll move on to the third diagram. So in the third diagram, when you make this triangular face perpendicular, as you can see here, the base will be in air. So to begin with, we always mark that point first, which we need on XY. So we'll mark A dash B dash on XY, and we'll draw a vertical line, or you can say a line perpendicular to XY. Then you can take O dash A dash B dash in the compass, and you can cut an arc here. So you'll get O dash and A dash B dash both. Once you get O and AB, you can obtain D by arc method. So we'll take AB to D in the compass, and we'll cut it here. Then we'll take OCD in the compass, and we'll cut on this side. By that you'll get the outer triangle. Then we can take AB to C in the compass, and we can cut on the base. Also we can take AB to M in the compass and cut it here to get the triangle. So I can say that this is that triangular surface. We can write here if we need. This is the triangular surface which is perpendicular with horizontal plane HP. That is what is being told. Correct? Now we need to project all the points from here and also from the pentagon to get the fourth diagram. Okay, so after I project all the points from the front view as well as the top view of the first stage, I am getting A, O, B, C, D, E and M. So step number 1, join the outermost points by dark line. So you need to join A with B, B with C, C with D, D with E and E with A. So the outermost point is almost like a pentagon. Now slant edge is a line joining the base corner with the apex. So we have drawn two slant edge O and OB as the boundary line. The remaining slant edge are O to E, O to D and O to C. Now what we need is a little bit of imagination. Compare both these diagrams. In the first diagram, the entire base was on HP, so you can see all the 5 triangles. Now we need this triangle OAB or this surface OAB to be perpendicular with HP. So we know that this set of the this page below XY, the area is HP. This area is HP, and we want this triangle, what I am shaded, we want this triangle perpendicular with HP. So if you look at this pentagonal pyramid, we can understand easily. So in the first stage, because the base was resting, you can see all the 5 slant edge, isn't it? Now this triangular surface, I need to make it perpendicular with the paper. So let me tilt and place an eraser for support unless it becomes perpendicular. To see first, this is not perpendicular. I need to further insert the eraser inside. So unless you can see it as a straight line. So finally what will happen is, now look at the top view. Now you can see that triangular face as a vertical line. So that is what we have drawn. So that is why A, O and B are on the same line. See, initially what happened is A was here, B was here and O was the apex. You can see them separately as a triangle. But the moment you tilt and try to make that triangular surface perpendicular, what will happen is AOB will fall in a single straight line. That is what you can see. Apart from that, you can see all the slant edges dark. So that is why all these slant edges have been drawn dark. So there are no hidden lines. So by mistake in exam, what students do is that they draw hidden lines over here. So I can say that this line is the triangular surface. This line is the triangular surface perpendicular with HP, isn't it? So this is the triangular surface perpendicular with HP. So in the last stage what they said is the same triangular surface, that is this triangular surface, should now be parallel and near to the vertical plane. Should now be parallel and near to the vertical plane. So what we have to do is that this same triangular face, so see, we know that the fifth diagram has to be drawn below in sequence 1, 2, 3, 4, 5, and moreover anything parallel with VP you can see from the top view. So XY line is our VP, and this triangular face what is now perpendicular has to be parallel, so you have to turn by 90 degree like this. So by doing that what will happen is this triangular face will now be parallel with XY and near to it. Okay, so in the fifth diagram what you have to do is that this was our XY line. Any distance below XY you should first draw a horizontal line, and this A you have to mark arbitrary anywhere. Then you have to take A to O and O to B in the compass and transfer it. Now this line OD is perpendicular to AB, so draw a line OD perpendicular to AB. Take the, on this line OD, M and this point will lie. So take O to M in the compass, transfer it here. Then take O to the circle what I marked and transfer it here. Now because OD and EC are perpendicular, so with respect to OD, draw perpendicular passing through that point what is being marked by circle. Take half of EC in the compass, cut on both the sides and reproduce the same diagram. Now observe is looking from this side, isn't it? So if you compare O with M, M is near means base is near, so base will be seen. So in the next diagram when you project all the points A, B, C, D, O, M from both the side, so step number 1 is join the outermost points by dark line. Step number 2, when you compare O with M, M is near means base is near, so base will be seen. So therefore we need to decide whether ED is dark or light or hidden, DC is dark or hidden. So because M is near, the entire base will be seen, so everything is dark. And moreover, if you switch on the bulb from here, you can see ED and CD, isn't it? Because that is within 180. So therefore ED and CD are dark. Now we know that whenever base is visible, it becomes a no entry area and the dark slant edge cannot pass through it. So we have drawn this slant edge hidden. And D is a dark corner, so we have drawn dark slant edge. So verifying from this side, O to D will be seen because it is within 180, but you cannot see OB and OA because they are beyond. So therefore OA and OB is shown hidden over here, whereas OD is shown dark. Okay, so the turning point of this question was, if you look at the second stage top view, and if you switch on the bulb, you can see everything from D to AB. So here all the slant edges are dark. But the question arises when you compare O with M, M is away, so base has to be hidden. Then why it is drawn dark? So the answer is, it agree that M is away, so base has to be hidden. But there are no lines left to be drawn hidden because all the base edges are being joined to form the shadow or the outline of the object. So there is nothing left to be drawn hidden. Okay, so that is about the 3 stage for this question. So the next question is, a triangular pyramid, side of base 40 mm and axis side 70 mm has one of its base edge on HP which is parallel to VP and 20 mm in front of VP. Draw its projections if apex is on VP. Okay, so we don't have a triangular pyramid right now, but pyramid, instead of triangle, if you consider square pyramid, the concept is not going to change. So let us consider a square pyramid, and we will read the question and try to position the solid. So in the question they have said a pyramid has one of its base edge on HP. So this is a pyramid. let us keep one base edge on HP as we're doing normally. Okay, so one base edge is on HP. Now the same base edge is parallel to VP, but right now if you look at this base edge from here, it is perpendicular with VP, and what we need is parallel to VP. So I need to turn and make that, so in the side view when you observe, so that base edge is now parallel to VP. Okay, so this was perpendicular to VP, now it is parallel to VP. If you further read the question, and 20 millimeter in front of VP, so this parallel base edge should be only 20 millimeter in front. So suppose this is 20, so from XY line the dimension is 20 for example, and they have said draw the projection if apex is on VP. So apex is on VP or not, you cannot make out from the front. See, in front view if you observe, it looks as if apex is already on VP, but when you look from side view or top view, you cannot make out whether, you can make out it is not on VP. So when I say it is on VP, you need to rest the pyramid like this. Okay, so this is the condition what we need. So again, now read the question once again to make it clear. A triangular pyramid rests on one of its base edge on HP. Okay, so one base edge is on HP, you can make out. One base edge is on HP, which is parallel to VP and 20 millimeter in front of it. It means VP. Draw its projection if apex is on VP. So apex should touch VP. So this is the last stage front view what you're supposed to draw in your book. So instead of square, the base will be triangle. That is the only difference, but the concept is going to remain same. And when you look in the top view, apex will be on XY. See, from the top view if you observe, VP is seen as a line, right? So apex will be in contact with XY, and in the front view if you observe, the base edge will be in contact with XY. So now let us understand which dimension is 20. So they are saying 20 millimeter in front of VP. So anything in front of VP you can make out from the top view. So see this resting base edge from XY. If you look at this dimension, okay, so this has to be 20. Okay, so have you understood what is 20? So 20 is nothing but the resting base edge is 20 in front of VP, and that can be understood only from the top view. It is 20 millimeter in front. So now how to break this into 3 stages, let us see. So let us go in the side view and focus on this 20 millimeter. So if you look thoroughly, 20 millimeter is the, this is 20, right? Okay, so in side view, this 20 millimeter is the horizontal distance. This 20 millimeter is nothing but, it is the horizontal distance between what? Between the resting edge AB and between the apex. So if you draw something like DBB, for example, from AB if you draw a vertical line, and from apex if you draw a vertical line, that horizontal distance is 20. Okay, so this is the third stage, front to top view. Now focus on this 20. What we'll do is that to go back to second stage without disturbing 20, I will not disturb 20 mm. I will turn this by 90 degree. So now if you look in the front view, try to understand what is 20 now. So if you look in the front view now, what is 20? Let us try to understand. So if you project apex down, the distance of apex from base edge is still 20, that is DBP is 20. And in the first stage, as usual, we need to make the entire base to rest on HP. So that gives an indication that you have to start from the top view and right side will be the base edge. In the second stage, tilt the solid such that the horizontal distance between the projector of apex O and projector of AB is 20 mm. In the third stage, turn the diagram by 90 degree and make the apex to touch XY. So this is what the concept is. So in the question they mentioned the triangular pyramid side of base 40 mm. So they are not mentioned the type of triangle. Is it a equilateral triangle, isosceles triangle, or scalene triangle? So because in the question they mentioned only one side has 40 mm, so it is understood that it is equilateral triangle. So in the top, you have to start from the top view where you need to draw a base edge perpendicular to XY AB of 40 mm, and taking that 40 in the compass, you need to cut from both the sides of A and B to get point C. So you'll get a triangle. To locate the apex, you need to draw 2 medians light and connect them so as to get O and M. Show dimension 40 here. Further, as usual, when you project AB, you'll get A dash B dash. Project C to get C dash B dash. You'll get axis of 70 mm length. Get a triangle like this. Okay. So first diagram, second and third. So as a special case, what we need to do next is, suppose this is that triangular pyramid. Now in the second stage, I need AB on XY. So tilt such that if you look at the projector of AB and projector of O, that horizontal gap should be 20. So it is something like dBp. So if you project O and AB, the horizontal gap should be 20. So in the next diagram, what we have to do is that you first mark AB on XY, that is A dash B dash. Move 20 mm and draw a vertical projector of O dash. So because the shape and size remain same, take AB to O in the compass, and from AB cut an arc. You will get AB O dash. Obtain C by using arc method. Take AB to C, cut an arc. Take O to C, cut another arc. You will get a dark triangle. From top view, if you project all these points down, you are going to get a outermost points as a triangle. Sorry, you have to join the outermost points. Second, if you look from above, compare O with M. Because M is away, base is away, so AB will be hidden. Even if you switch on the bulb, you can see everything from C to O. You cannot see AB, and therefore AB is hidden. Finally, you need to mark the axis M. So remember that the horizontal distance from O till the hidden line AB, this is 20 mm. Now what we need to do in the third stage is, so if you look at the top view, for example, this was a square pyramid. So in the next stage you need to turn such that the distance between projector of O and AB is how much? 20. Now suppose my hand is VP. So last stage what they said, the resting base edge is parallel to VP. So AB has to be parallel to VP, means XY, and apex O, that is this point O, should rest on XY. So to turn in this direction by 90 degree so that the base edge becomes parallel, and apex should touch my hand. That you can see only from top view. So in the next stage what we have done is, this diagram we have turned by 90 degree. So first we have made this point O to rest on XY. So fifth diagram is here. So make this point O to rest on XY. Draw a line perpendicular to XY. Take the distance from O to hidden line till M. O to hidden line till M. Then if you look at this point, take half of AB in the compass and cut left and right, and reproduce the same diagram. Now looking from this side, if you compare apex O with M, M is near means base is near. So therefore base will be seen. So after projecting all the points, join the outermost points by dark line first. Okay, second step, if you look at the base ABC, it will be seen because M is near. Moreover, if you switch on the bulb, you can see C to B and C to A, so therefore they are dark. And finally from dark corner, draw dark slant edge CO. So that is the third stage of the given question. So next question is a pentagonal pyramid 40 mm base edge and axis height 70 mm rest on HP such that one of its triangular surface is parallel to HP and perpendicular to VP. Draw its projection is apex is near to the observer. Okay, so I hope one point is clear, that this apex near to observer you can see only from the top view. For example, if this page is HP and my hand is VP, so in the top view this is the second stage for example, and observer is looking from this side. So apex, if I turn like this, it can be understood that it is near to the observer, and if I turn like this, it is away. So apex near, apex away can be seen only from top view. That concept has to be clear. See in front view what happens, suppose this is the front view, first stage, second stage. So in the third stage, if I tilt like this or like this, you won't understand whether apex is near or away. It is difficult to make out in the view. Okay, you cannot make out whether this is near or away. So apex near or away can be understood only from the top view. So now let us see practically how to position the solid. So we have a pentagonal pyramid here. So they are asking us that the pentagonal pyramid rest on HP such that, so you need to make this to rest on HP. So okay, it's resting on HP such that one of its triangular surface, so out of five triangular surface, any one triangular surface has to be parallel to HP and perpendicular to VP. So if we turn like this, for example, so let consider this triangle, place it such that this surface is parallel with HP, so it has to be like this, right? So it is parallel to HP, and anything parallel to HP can be seen only from the front. So look in the front, so this triangular surface is seen as a line which is parallel to XY, isn't it? And if you extend this triangular surface, it is perpendicular with VP. So if I slowly place this, and if I look from the top view, you can see that corner is on the right side and the triangular surface is on the left. So in the next stage what we'll be doing is, so it's a corner resting question. So in the next stage when you tilt such that the triangular surface has to be parallel with HP. So see, in the top view you cannot make out whether the triangular surface is parallel or not, because if you tilt a bit more it still looks to be parallel. So parallel to HP can be understood only from the front. You can see that only from the front you can make out whether that triangular surface as a line is parallel or not, and also perpendicular to VP. But this is not the end. They have said that draw its projection if apex is near to the observer. So in the top view what you need to do, you need to tilt the pyramid in the third stage such that apex is near to the observer or away from VP. So you have to turn by 90 degree. Okay, and the question has to be like this. Okay, so this is our last stage, front view and top view. So if you look at this last stage front view, the top triangle is perpendicular with VP. The topmost triangle, which is seen as a line, is perpendicular with VP as well as parallel to HP. So this is the third stage. What we'll do in the second stage is, in the second stage we will tilt this by 90 degree and make the axis parallel to VP from the top view. And in the first stage we'll make the entire base to rest on HP such that corner should be on the right side. So as it is a corner resting question, we need corner on the right side. So to start with the bases on the left. So draw a line of 40 mm, draw 108 degree, mark 40 on each side and complete the pentagon. Also locate O and M and draw 5 slant edge dark. In the next view, by projecting A, E, B, C, D, O, M, you can get a triangle dark and marking the axis as 70 mm. So in the second stage, because the first stage condition is with HP, second should also be with HP. We know that. So in the second stage, I want this corner A dash to remain on XY, because they said in the question, rest on HP such that. So something should rest on HP, either a base edge or a base corner. So we are making this base corner to rest on HP. Okay, so corner A dash will rest on XY. And we want the opposite triangular face, because we are going to make this triangular face parallel to HP and perpendicular to VP. Okay, so as I told that in the first stage you are drawing this pentagon like this. Second stage we will make this triangular surface parallel with the paper that you can see from the front, and also the surface, if you extend, it is perpendicular with the vertical plane. Suppose my hand is the vertical plane, so this triangular surface, when you extend, it has to be perpendicular with VP. So now the concept comes back again. If you want a point on XY and opposite line to be horizontal, you need to draw a perpendicular A dash P dash. So if OCD is horizontal line, so the perpendicular has to be vertical. So in the next stage what we'll be doing is, in the next stage you will mark A dash first, draw a line perpendicular to XY, take A to P in the compass and transfer it here. Once you get P dash, draw a line parallel to XY, and logical thinking, P dash to O dash will go on the right side to take in the compass P to O and cut on the right. Take P say CD, cut on the left, draw the outer triangle. Take the remaining point A to B and A to M in the compass and complete this diagram. So now this is the triangular face, because there are 3 points. So this is the triangular surface which is both parallel and perpendicular to HP. So this triangular surface I can write here. This is the triangular face which satisfies both the condition parallel to HP and perpendicular to VP. Parallel to HP and perpendicular to VP. So when you look in the top view, you first need to join the outermost points by dark line, correct? So that is what is being done. Next, in the top view, if you compare O with M, M is away, so base is away. So base has been drawn hidden here. Also, if you switch on the bulb, you can see from O to CD everything. The base will not be seen. So base is drawn hidden. The lines which are left out is drawn hidden. As there are 5 slant edge in pentagonal pyramid, we have drawn only 2. We have drawn only 2 slant edge. So for the remaining slant edge, we need to understand that from dotted corner draw dotted slant edge, and from dark corner you have to draw dark slant edge. Again, if you look from the top view, you can see the triangle OCD. So therefore OC and OD is dark. You cannot see triangle OA from the top view. Sorry, not triangle. You cannot see the slant edge OA from the top view. So O to A is hidden. So now in the last stage, what they said, that observer is on this side. They want apex near to observer. So question is that why we should tilt this by 90 degrees. So this is the pentagonal pyramid. Okay, like this. So in the last stage, observer is here. So why we should tilt this by 90 degrees? Because even if I tilt a little, the apex will become near. So why we should tilt by 90 degrees? That is the question. Even if you tilt a little bit lesser, apex will still be near. So if you read the question thoroughly, they have said base edge containing that triangular face is parallel to VP. So which triangular face? The one which is under consideration. So if you look at this triangle, out of this triangle OCD, CD is the base edge. Okay, so in this case, CD is over here. This line, this edge is CD. So they have said to turn the pyramid such that apex is near to observer, and this edge CD has to be parallel with the vertical plane which is behind. So this line has to be parallel. If I tilt a little, it will not be parallel. The CD will be inclined to VP. So to turn unless and until this CD becomes parallel to VP. So you can see that parallel only from the top view. So therefore, this diagram we need to tilt by 90 degree. So to begin with, first draw a line horizontal CD parallel to XY. And by logical thinking, when you turn, D will go on the right side. So take half of CD in the compass and cut it twice to get C. Now CD and axis are perpendicular. So from CD, draw a line perpendicular. And on this line, mark all the points like M, this projector, A, O. From this point of CD, take all these points in the compass and mark it on this vertical line. So we get A over here. Now to get B and D, take half of B in the compass and cut left and right. So from this circle, you have to cut left and right. You will get B and D and reproduce the same diagram. Now observe looking from this side, right? So because OCD is parallel, you will get this as a horizontal line. So why OCD is horizontal? Because it is not a slant edge, it's a triangular face which is parallel with HP. So anything parallel to HP you can see in the front view. So therefore OCD is parallel to XY. Also, if you extend OCD behind, there is a vertical plane. This area above XY is what vertical plane. You can make out the surface is perpendicular VP right in the beginning only. So step number 1, join the outermost points. Again the case remains same. What is happening is all the base edges are covered in the outline itself. So there is nothing to draw hidden. Even though if you compare O with M, M is away. So base has to be away. But here everything is being covered by the outline itself. So this is the final stage. And finally what you're getting is you're getting one corner on HP and opposite triangular face parallel to HP.